Hello, and thanks for using TickBoom. For this question, a student is interested in how to answer question 16, part 2, as you see here on screen. So the question is about essentially a classic permutation and combination question. So the facts are there are 3 identical blue marbles and 4 identical yellow marbles arranged in a row. How many different arrangements of just 5 of these marbles are possible? Alright, so as with most of these kinds of questions, the best way to start to tackle it is to draw up a diagram to try and visualize what we're dealing with. So let's get started by doing that. Okay, so we know from the question that we have 3 identical blue marbles and 4 identical yellow marbles. So we've got a total of 7 marbles that we're choosing from, but we're told we want to know the number of ways that you could pick 5. So if I draw a square for each of the 5 spots that a marble can go in, we're essentially asking, from the 7 marbles we got to choose from, how many ways could you choose 5? Now for these kind of questions, a good way to tackle or to get started is to ask yourself, well, what are the different combinations of blue and yellow that could get you 5 marbles? So the first combination would be if we had 1 blue and if we had 4 yellow. That would get us 5 marbles. The next combination would be if we had 2 blue and 3 yellow. That also gives us 5. And then if we had 3 blue and 2 yellow, that also gives us 5 marbles. And actually that's all there is. They're the only 3 ways you can get 5 from the 7, because there is only 3 blue and only 4 yellow. So there's no other combination of blue and yellow that will add up to 5. So now that we've got our 3 possible ways in which you can get 5 marbles, the question simply becomes counting up how many ways you can do each of these and then adding them up, and that gives you the total number. And for this purpose, the general formula that you can use is that the number of ways for each case would be equal to x factorial on y factorial times z factorial, where in this case x is equal to the number of spots that we're trying to fill. So in that case it's 5 for this problem. Y would be equal to the number of blue marbles that we're inserting for each case, and then Z would be equal to the number of yellow marbles. So that then becomes a fairly simple exercise of arithmetic. We can just fill out this formula for each of these 3 cases. So the number of ways for the first approach would be equal to 5 factorial divided by 1 factorial times 4 factorial. And hopefully you can work out that that is just equal to 5, but just as a double check, let's put it into our calculator. So we're going to get 5 factorial divided by bracket 1 factorial times 4 factorial bracket equals 5. Perfect. Now we're going to ask, for the second case, we're going to say it's 5 factorial on 2 factorial times 3 factorial, and that's going to be 5 factorial divided by bracket 2 factorial times 3 factorial bracket equals 10. And then finally we have 5 factorial divided by 3 factorial times 2 factorial. Now I don't need to rekey that into the calculator because 2 times 3 is the same as 3 times 2, so we're still going to get 10. So we can see that the total number of ways to pull out the 5 marbles from the 7 on offer is equal to 5 plus 10 plus 10 which equals 25. And that's where you could finish for the purposes of answering the question. If you were doing this in the context of an exam and you found yourself with some spare time to check your answers, with these kind of questions, one thing you could do as a check is to actually list out all the ways and make sure it does make sense. So, for example, in this first case where I'm always picking 1 blue and 4 yellow, the ways I could do that would be to go blue, yellow, 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 yellow. That's one way. I could go yellow, blue, yellow, yellow, yellow. I could go yellow, yellow, blue, yellow, 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 blue, yellow, and then yellow, 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 blue. Hopefully you notice the pattern of each time the blue is just taking up a different spot, because there's only ever one blue, and that adds up to 1, 2, 3, 4, 5. So there's a check that 5 does make sense there. Now, in terms of case 2 and all the different ways you could pull out 2 blue and 3 yellow, again, same approach, just try listing them all out. Now, we know, or we're pretty sure that there'll be 10 of these, so twice as many. So let's just see if we can work out what they are. So I'll just make space. 1, 2, 3, 4, 5, and maybe 6, 7, 8, 9, 10. So let's see if we can fill out all the different combinations of 2 blue and 3 yellow. So first way would be I just take blue, blue, and then yellow, yellow, yellow. That's one way. I could then go blue, yellow, blue, yellow, yellow. And see, I've shifted this second blue over 1, and I'll just keep doing that. Blue, yellow, yellow, blue, yellow, blue, yellow, 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 blue. So I've followed that pattern of shifting over the second blue. Now let's try that with the first blue and shifting that over. So we'll go yellow, blue, yellow, yellow, blue. Then we'll go yellow, yellow, blue, yellow, blue. And then we'll go yellow, 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 blue, blue. And now we started with the 2 blues, and now we've ended with the 2 blues. And now we can think of a few more ways where these 2 blues are sitting in different spots, so not the very beginning or the very end, but in the middle. So we could have one where we go yellow, blue, blue, yellow, yellow. That's one. Could have another where we go yellow, yellow, blue, blue, yellow. That's the other. And now the last possibility is where they all alternate. So yellow, blue, yellow, blue, yellow. And there we have the 10 different ways that you can arrange the 2 blue and 3 yellow. And actually the 3 blue and 2 yellow, it's just the same combination, but with the blues and yellows reversed. So there's probably not a whole lot of value in repeating that exercise. So there you have your approach. You've got your formula that helps you work out the number of ways. And it's really just simply adding it up, and then if you do have the time on the exam, you can check it with brute force. So hopefully you found that helpful, and tick boom.